Hello everybody, and welcome to Logarithms. Today, we are going to do two things. First of all, we're going to learn what a logarithm is, and then learn to convert between exponential form and logarithmic form. And then we are going to learn how to evaluate logs without a calculator and then with a calculator. All right, so let's go ahead and jump into it. So first of all, what is a log? Well, let's just look at a problem, okay? So let's start with solving for x, 2 to the x equals 8. Now, we can kind of look at this very quickly. We know that 2 to the third power equals 8, so we know the answer is 3, right? But let's just kind of go through this a little bit. So logs are the inverse of exponents, and they can be used to help us find variable exponents. So in this case, right, we have 2 to the x equals 8. We know x is 3 because 2 to the third equals 8. But what's going to happen is in our math, we're not always going to get very, very neat numbers, and we're not always going to get numbers we know the answer to immediately, right? So there are going to be times where we need to be able to break these down, and logs are the ways that we can break them down. So if we rewrite this, 2 to the x equals 8, we can actually rewrite it in this form, and this is what is known as logarithmic form, right? This first form that we talked about was known as exponential form, and this down here is known as logarithmic form. And I'm getting a little bit ahead of myself, but just want to kind of show you what these are, okay? This is the base, right? If we look at our original exponential equation, 2 is the base. We have a log with a base 2 of 8, right? And 8 is actually what is known as our result. It's this thing here. And that equals x. And x is the exponent, right? So this is what is known as logarithmic form. All right. The way you read this is log base 2 of 8 equals x, or is x, right? Is and equals are the same word in math. So since 2 to the third power equals 8, x equals 3. And then I talk about this being exponential form, this being logarithmic form. And you have to note there are very specific things that are always true, right? So for log base b of x equals y, b has to be greater than 0. The base cannot be negative. The base cannot equal 1, because imagine if we just look at like here 2 to the third, right? If this 2 was a 1, it doesn't matter what the exponent is. 1 to the anything is 1. So it actually doesn't create exponential growth or decay. So it's actually not an exponential function if this is a 1. And then x has to be greater than 0. All this means is that our result has to be positive. And that's also true because if b is not negative, right, so x has to be positive. Okay. So converting between forms. Now we kind of talked a little bit about the different forms before, right? So if we convert 3 to the fourth equals 81 into a log form, first let's talk about what it means in exponential form. This is saying base 3 to the exponent of 4 equals our result of 81. Right, base 3 to the exponent 4 equals 81, and 81 is our result. Now, when we go to create a log, I think of this as like a step-by-step process. This is the way I personally do it. I think a log equals an exponent, right? So the log part of it is going to equal the exponent part of it. And the other thing that's always easy to remember is the base, because the base literally uses the same word here. We don't use the word result a lot in math, right? We use like product, stuff like that, right? So the 81 is the part that like I usually fill in last. So I usually write log with the base, and then I kind of leave a space, and then I put equals the exponent, because a log is an exponent, or a log equals an exponent. So log base 3 of 81 equals 4. This would be the logarithmic form of this exponential form. And they're the exact same. These are the same value, right? They're just written in different forms. And we're going to talk about what we can do with this, right? Right now, it just kind of looks like we're doing this for no reason, and that makes sense because we haven't done anything yet, right? But this is how you convert from exponent form into log form, and vice versa, right? You can go back the other way. And I'm going to show you how to do that now. So convert log base 10 of 1000 equals 3. Now remember, the easiest way to do this is to think the answer is the exponent, right? A log is an exponent, and then 10 is our base. So think a log equals an exponent, 10 is our base, right? Because we have log base 10 here, 3 is our exponent, and then this extra piece here is our result. And this is how you would convert from log form into exponent form. All right, and now you're ready to start looking at problems. All right, so let's evaluate logs. And this is going to be evaluating logs without a calculator, because there are very specific things we have to do in order to be able to convert them in a calculator, okay? Or on a calculator. All right, so first let's evaluate log base 5 of 125. Now, first thing we're going to do is we're going to rewrite this as an exponent, because trying to solve it like this, you'll learn how to be able to look at this and kind of already put it into exponent form in your mind, and then you'll be able to solve it pretty quickly. But for now, let's just write it in exponential form, and so we can see it, so we can solve, right? So if we rewrite this, remember 5 is our base, and 125 is our result, right? So 5 is our base, 125 is our result, x is the thing we don't know, right? Because this doesn't say like equals x or anything like that, right? We don't know. So x is our exponent here, right? So basically 5 to the what equals 125. Well, we know that 5 to the third is 125, so we know that x has to equal 3. So in other words, log, and what this equals is, right? So log base 5 to the 125, this equals 3, right? If we like put this in, right, if we want to use this as a number, this number is just 3, right? That's what this thing equals. So log base 5 of 25 equals 3. I know it's kind of hard to think of it that way, but like all of this mess here, the log base 5 of 125, this is the same thing as saying 3, right? And that's because 5 to the third power is 125. Okay. So let's try this one, okay? So that one wasn't too bad, right? Because 5 to the third power is 125. That's something we know pretty easy. They can do little things to try to mess with you, though. So let's do number 2, okay? Log base 1/4 of 16. Now remember, the 16 is the answer, right? And we don't know the exponent yet, because that's what this will equal, right? The exponent is what this will equal. So what we're going to do is rewrite this first, right? Base 1/4, power of x, because we don't know what the power is yet, and that equals 16. Now, I put this little note over here for you, right? Remember that if we have a to the negative x, that's the same as 1 over a to the x, right? Which means that if we had like 3 to the negative 2, we would have 1 over 3 to the 2, which is the same as 1 over 9. This is important to remember, right? Because we're going to need that to solve this problem. Because we know that 4 squared equals 16, right? So we know that 1/4 to the negative 2, right? 1/4 to the negative 2 also equals 16. Because if we need to take that 1/4 and we need to turn it into a 4, right? So in order to turn the 1/4 into a 4, we need to find the reciprocal, which means if we knew, right, if we know that, like if this was just a 4, if it was 4 squared equals 16, we'd be done, right? But we need to turn this into a 4, and the way we do that is by finding the reciprocal. In order to make it the reciprocal, we have to take the negative of the exponent, right? That's what I was kind of showing you over here, right? We're kind of going backwards from what I showed you, but it's the same concept, right? So you take the 1/4, you flip it by making it a negative. So we know that 1/4 to the negative 2 equals 16, right? And now that we know that this is true, we know that the exponent is negative 2, so that's our answer, right? But we can rewrite it as log to the 1/4, or base 1/4 of 16 equals negative 2, and negative 2 is our answer. So if we look at this and we said, what is log base 1/4 of 16? The answer is negative 2, right? That's what we were looking for. All right, let's do a couple more. This one will kind of reinforce the concept we did before. We have log base 3 to the 1 over 81, right? That means we don't know what the exponent is here, right? But we know that 3 to that exponent is 1 over 81. Now, we know that 3 to the 4th is normally 81, right? 3 to the 4th is 81, but this is a 1 over 81. So we have to use our negative exponent in order to flip it, right? So in this case, if 3 to the 4th is 81, 3 to the negative 4th is going to be 1 over 81. So in other words, we know that this has to be negative 4, this x has to be negative 4 in order to make this fraction like this, right? So log base 3 of of 1 over 81 is negative 4. This exponent is negative 4, and that would be our answer. Okay, now, when you get a problem like this, I thought this would be instructive, right? You'll notice how we have 3 to the x equals 0. You can't have a result of 0 when it comes to a positive exponent, right? So this is undefined. And that's what, when I show you over here, right, the rules that we came up with, right, our result can't be 0. We already talked about that, right? So just make sure that you're careful for these things, because if you try to rack your brain over like what exponent creates 0, you're going to be doing that literally forever, because it doesn't exist, right? So that's why it's important to kind of just familiarize yourself with these rules. You're not going to see it a lot, but if you get a problem where it doesn't seem to make sense, the answer doesn't seem possible, there's a good chance that it isn't. Okay, so there are times when logs can be undefined because negative exponents can often imply things like, well, not negative exponents, but negative results can often imply imaginary numbers. So that's why sometimes these things aren't defined. Okay, so all that stuff was awesome, right? Learning how to do it without a calculator, but 90% of the problems we're going to solve are going to be with a calculator. Okay, so let's learn how to do that. Now, the only thing is if we look at our calculator, right, if you actually go to your calculator and you type in, you try to type in log, like hit the log button on your calculator, you're going to notice that it gives you a space, but there's no space to put a base, right? That's because your calculator isn't going to perform anything with a base. You need to have it not have a base. And while it's that's actually a poor way of wording it because it still has a base, but we need to put it into a form your calculator can recognize, all right? And there's two forms your calculator recognizes. Actually, if you look at it, you'll see log, and then I'll go ahead and delete this here and just type it in because I don't see how to do it on this website. But if you click ln, right, on your calculator, this is the natural log, and these are the two things we're going to be talking about. All right, so we have common logs, which are logs with a base of 10. If it has a log base 10, it's not even going to write the little 10, right? So if we look back at this problem, like over here, right, where we did convert log base 10 of 1,000 equals 3, normally you wouldn't even put the little 10 down here, right? I put the little 10 down here just to show you for continuity's sake, like so you can learn it, right? But what it really is that we have, like for instance here, we have log with a base 10. These are known as common logs. So log of x is the same as log base 10 of x, okay? But your calculator can put this in. You could put, well, putting log x in your calculator wouldn't do anything, but you could put log of a number into your calculator and it'll pop out an answer, right? And what that means is 10 to that power equals whatever the result would be, right? That's kind of what it's figuring out. Now, natural logs are the same thing, but instead of having a assumed base of 10, they have assumed base of e. And if you remember back from your problems before, we had the form. I can just kind of write it out here, right? We had like p e to the power rt, right? So we had a base of e. So when we do some of these problems, we're going to need to get rid of these exponents, right? And when we go to get rid of these exponents, we're going to need a base of e. So that's the reason why we need the ln as well, right? The ln is kind of the anti-e. It kind of cancels it out a little bit, the same way a log cancels out an exponent, right? So that'll actually be really useful when we get into that, which will be in future lessons. So just kind of wanted to show you where that came from. Now, we're going to do a couple here, but I just wanted to kind of tell you what these are, right? If we can make a log have a base 10 or a base e, right, then we can actually use the common log form or the natural log form to put it into our calculator. So let's just use our calculator real quick. Let's go ahead. We're going to just evaluate this first part. All right, I kind of did some of the math here already just to kind of show you, but we're going to start off, well, that wasn't great. Okay, we're going to start off with log of 900, right? So when you evaluate log of 900, it's literally as simple as going into your calculator, right, hitting the log button, which is on like the bottom left of your calculator if you want to use that, and then just typing in 900. And now it'll pop up a number, 2.954, right? So if we go back here, right, 2.954, this is the common log. Now, what this means, and this is important to remember, right? Remember that the base is 10, right? It's assumed that right here, there is just a little 10, right? This is the base, but we don't write that, right? But if we think about what this would mean in exponential form, it would mean 10 to the 2.954 equals 900. Okay, and we'll come back to this in a second because I'd really like to test your understanding of what these concepts are, just conceptually. I think it'll be helpful. So yeah, remember that b is assumed to be 10, right? Our little base is a little 10 here. It's never going to be put into it because you can't put that into your calculator, but anytime it doesn't show the base, it is a base of 10. Okay, so now let's do the ln of 350, all right? And the ln of 350 is going to work the exact same way. If you see the log button on your calculator, the ln button is very similar, or it's very close, I should say. So we're going to clear this out, and on your calculator, I'm just going to type in ln, and that'll pop up the ln here. And then we are looking for the ln of 350. So let's just type 350. And we get 5.858, right? So if we go back here, we get 5.858. And remember, this is, if you see the ln, right, of 350, what this is kind of saying is the ln base e, right? The ln implies like log base e, right? That was probably hard to see what I did there, but that's supposed to be a little e. But yeah, so log base e is the same as ln, okay? So the ln of 350 equals 5.858, meaning that e to the 5.858 equals about 350, right? This is approximation. Now, if you want to know if you're really getting this or not, right? Remember that we talked about this log being an exponent, right? The logarithm, the whole point of this logarithm is to evaluate what an exponent is. So I want you to just pause the video for a second. Can you tell me, remember, this is log of 900, and we're talking about a base of 10, right? So this isn't quite 3, right? It's 2.9 something. And this is 900, and we have a base 10. 2 to the third would be 1,000, or 10 to the third would be 1,000, right? Do you see this makes sense, right? 10 squared would be 100. I guess I'm just going to explain this. Don't worry about pausing the video. 10 squared would be 100, right? Do you see how 900 is much closer to 1,000 than it is 100? Well, this number is much closer to 3 than it is to 2, right? So you can see that we're literally evaluating, we're figuring out what the exponent is, okay? That's the whole point of what we're doing here. So hopefully that made some sense, right? In the same way that you can look at, like if you have the square root of 26, right? The square root of 26 is much closer to the square root of 25 than it is the square root of 36. So we know that the square root of 26 is much closer to 5 than it is to 6, right? It was kind of it's a nice little mental math technique, but it's also a good way of just kind of quickly checking your work, right? If I know that 10 to the third is 1,000, does 10 to the 2.9 equals 900 make sense? Well, yeah, it does. It makes sense quite a bit, right? Okay, that's just kind of help you like get a mental grasp of it. But all right, let's go and solve problems with logs. So now we're going to solve like things with equations, and now you're going to get to kind of see how logs can actually help us like in the real world, right? Okay, so let's try to solve 25 equals 10 to the x minus 1. All right, let's do it. So first we're going to convert it into a log, because the reason why we convert it into a log is because think about, if you think about logs as the inverse to exponents, right? We need to unexponent this, right? If we needed to unmultiply something, we'd divide. If we needed to unadd something, we would subtract, right? If we need to unexponent something, we have to log, okay? It's like, this is the best way of looking at it. So we need to take this log out of the exponent in order to even be able to talk about it, right? So let's convert it into a log. Now, log of 25, right, equals 10, or sorry, 25 equals 10 to the x minus 1. Well, what's our base? Our base is 10, right? Perfect. Now we know that because we have a base of 10, we can use our calculator to help us, right? And I'm going to show you how to turn this into base 10 when it's not. Okay, so we're going to do that in a future video, so don't worry about that too much. But for now, they gave us a nice one with the base 10, so we can do this, right? So this is going to be log base 10 of 25 equals x minus 1, right? Now I didn't write the little base 10 because I want you guys to get into the habit of seeing this without having the little 10 there, because this is what it's going to look like. All right, so log of 25 equals x minus 1, right? And again, we don't need to write the base for the common logs. Now, I'm trying to solve for x, right? So what am I going to do? I'm going to add 1 to both sides. And this looks really weird, right? 1 plus log 25. But remember, log 25 is just a number, right? So if we put in log 25 on our calculator and then just add 1 to it, we'll get our answer, right? So let's do that. So go back here, log of 25 equals 1.39, and I'm just going to hit plus 1. Hit the send button, I guess. Okay, 1.41. What did it do? Okay, hold on. Oh, it's doing the log of 25 plus 1. Okay, my bad. I see the issue. Okay, so log of 25, and I just want to evaluate that. And then maybe outside the parentheses, yeah, here we go, plus 1. Okay, so yeah, it was just doing log of 26. That makes sense. Okay, so we get 2.397 right? Which is 2.398. We rounded a little bit, but yeah. Does that make sense? So hopefully that was instructive, actually, the mistake I made. Make sure that when you do the log, that the 1 is outside. If you try to do it all in one step, make sure that the 1 is outside the parentheses. Otherwise, you're just going to be taking the log of 26, right? Which isn't what we want. So, all right. Awesome. So let's go and try this one. So this is a good time to pause the video. See if you can figure this one out. So we have the ln of 2x plus 3 equals 4. Like I said, go and pause the video, and we'll come back together and give it a try. All right, so let's go and give this a shot. So we have the ln of 2x plus 3 equals 4. So remember, we know that the ln of this means that e is the base, right? So we also know that we have the 2x plus 3 here, right? So if we want to look at this, right, we can just do this real quick, right? This would be e to the 4th equals 2x plus 3. Remember, e is just a number, right? We can do e to the 4th. So we're actually converting the other way to help solve this one, right? So let's do this. E to the 4th. That didn't do it. Let's use our algebra skills. This is e, and this is to the 4th. 54.59. Okay. So if we get on here, this is 54.59, and that equals 2x plus 3. And hopefully now you see how, like, this isn't too bad from here, right? We're going to subtract 3, so minus 3, and then we're going to divide by 2, divide by 2. So 54.59 minus 3. Oh, I tried to do it again. All right. The calculator is being annoying for me, so hopefully we can figure this out from here. 54 point, let's just go back to the old-fashioned calculator. 54.59 minus 3, 51.59 divided by 2, 25.795. 25.795. Okay, now I wrote that down for a reason, right? Because I want to show you that we can check our work, right? So if we pull back up our calculator, right? Remember that this is what we're determining this x to be, right? So if we plug that in for x, we can kind of like show how we could do this. So we can say the ln of 2 times 25.795 plus 3, right? And that should equal e to the 4th, right? It's kind of the idea. Or no, that should equal 4, sorry. We're going back to the original equation, so that should just equal 4. So, I mean, we're going to probably get a rounded number, right? Because this is approximately, but let's do this. So let's do 2 times 25.795. That'll give us 51. Oh yeah, it's going to give us the 54. Brain isn't completely on point today. But yeah, so this is going to be the ln of 54.59. And if we go back here, the ln, oh yeah, that's right, 54.59 ln 3.99999, right? It's 4. All right, so that's how we could kind of check our answer, right? By going backwards, which is kind of like just an algebra, right? If you go backwards, you can kind of check your answer by plugging it back in. That's kind of what we did. We just plugged it back in, right? Where the x is. So, awesome. That's it. You guys have done the very basics of logarithms. We learned what a log is. We learned how to flip it between forms. We learned how to evaluate logs without a calculator. Then we learned how to evaluate logs with a calculator. And then we just tried solving a couple problems where we actually have equations. All right, well, that is it. Good luck, and I will see you in the next video.